everybody. Thank you for joining us here at Collision. So I'm really excited to introduce to you our friend here, uh, Dennis. And Dennis is actually a mobile developer advocate. But he's from Seattle, and he's here to talk to us about 4 different ways in which you can learn different machine learning for mobile. Dennis, you want to kick us off?
Sure.
Thank you.
Can you hear me okay? All right. So we may have some Wi-Fi issues. This talk has a couple demos, like 4 demos, and 2 of them are live, 2 of them will be offline to kind of demonstrate the whole purposes, but Wi-Fi has been really sketchy, so we'll see how it goes. But I got a couple screenshots so you get an idea of what we're doing. So again, my name is Dennis. I've been with AWS 6.5 years, based out of Seattle, and I'm a developer advocate for mobile developers. So any mobile developers wanting to use AWS services, I help them out with whatever we have, the tools. We have App Sync, Device Farm, SDKs, any kind of mobile development you want, setting up a lot of serverless environments, API gateway to Lambda, those kind of things. Today, we're going to be talking a little bit about AWS, but the most of it we'll just be talking about in general. As a mobile developer, how do you get started with actually being a practitioner using machine learning, not actually teaching how to train it and all that. But most of the stuff we're talking about today will be all about inference. You know, there's 2 parts to machine learning, right? There's training a bunch of data on images and sounds and text, and training a model. Think of it like just a model of the brain, and then taking that brain and putting on a device or putting it behind an API, and then calling inference on it or prediction. So those are 2 sides of it: the prediction inference side, which is what we're talking about from a mobile side. So the model sitting on a device or calling an API. So when I talk about the 4 ways, we're going to be calling either an API with some of the machine learning API-driven services through AWS, or train a model and then bring it back onto the device so we can do completely offline. And it just depends on what type of app you want to build. Now, machine learning has come a long way. The accuracy has really improved with a lot of the vision and everything. So I want to talk about some of the options too, as far as using some of the Apple and Android core frameworks that are available to us from the Vision framework. There's a lot of services out there that provide all that for you, but there's a lot of built-in systems inside the SDK. So if anybody heard like Amazon Lex, it's a Lex chatbot that takes a voice and transcribes it into text and then sends the text to a Lambda function and does some certain things. Well, on the device itself, he can be completely offline, and our voice will be recognized and put into text, and then we could send it to an API-driven managed service or do whatever we want with that text. And we save another API call, and we're fully offline, not connected to the internet. So those are kind of things we want to talk about. So when I talk about the model itself, the model is just this trained model, either in the cloud or on a desktop, and then put on a device or put behind an API gateway. Anybody use machine learning right now in their app? Okay, good. Few of them. So it's going to be, in the next year or 2, it's going to be a standard. It's not going to be like I got machine learning on my app. It's going to become a norm. As you've already seen, a lot of services like the cloud share, the cloud photos, iCloud, all those photo sharing, you'll see that it identifying faces as you upload them and identify places. So I can go into my photo album, and it'll identify my kids. It'll identify what location I was. All the photos I've taken in Toronto, it'll categorize that. So it pulls up information. Some of it's machine learning. Some of it's just tagging, just straight up tagging from geolocation. But there's a lot of that going on. And then a lot of that call ahead, the type ahead stuff like Google and Gmail. Has anybody used that feature where you're typing and all of a sudden it'll predict what you're going to say? Those are kind of things that are going to be normal for you as a mobile developer to put into your app, because customers are going to expect it, right? Because all these other customers developers are doing it, and these bigger customers are expecting this. So as you release an app that just simply has photo sharing and chat, you're going to have to be putting up photos and tagging those, whether it's a geolocation or tagging with certain folks, certain images with just people and dogs, whatever it might be. And then the same thing with a chat app. Maybe you'd want to do predicted text, so you can actually save some time, so when people are chatting back and forth, you can kind of predict the next few words that they're going to say. So those kind of things you can build in today with machine learning inside your apps. Another example of the norm is, anybody have a security camera app that identifies your dog or your family members? Anybody have that? Not yet? Okay, you will, or you want to. The next security systems, all of them at least the last couple years, have come out. Remember ADT security, you got a camera, closed caption, you got Wi-Fi cameras. Well, now it's the norm where you buy the service and you could train it on your family. So remember we have a camera outside and it's a windy day and the bush is moving, it's false alarms, you want to trigger motion, somebody drives by, it triggers motion again. You want to be able to be succinct and be only notified with certain issues with your camera. So nowadays they have this, a lot of the services will do machine learning. So you set up and you take pictures of your dog, your family members, the 4 families, kid, the wife, and then it identifies it. And you can set up alerts to only alert on family members or only alert on non-family members. So if somebody comes to the door and it's your kid, you can alert a certain way or not alert at all. Or if it's a UPS person that you haven't met before, it alerts and says somebody unknown is coming to your door. So this is going to be normal when you go and buy these kind of products, and then these are going to be built into mobile strategies as well. A lot of things you see in Deep Lens. We have a product that's Deep Lens and has that camera where it's a lot of the time machine learning. This is the kind of things we want to start doing in mobile apps. We release it and the customers are going to be expecting it. So when you think about machine learning, just think about it's kind of going to be the normal thing, and we're going to want to utilize those frameworks for that. So when we talk about 4 ways, I kind of divided it into 4 areas. We have pre-built machine learning, which we'll talk about all 4 of these and do some demos. So we have online and offline, and it just depends. Certain products, like if I'm in the cocoa plantations, and I'm in the field in Colombia, and I'm out there in the field, I'm looking at diseased plants. There's a model out there that a lot of scientists have built. The model can tell me if I take a picture of a banana plantation or a leaf or plant, it'll tell me it's diseased. It'll tell me what stage it is in. I can do that completely offline because at some point I went to a cafe, downloaded that model, and it's completely offline. I have a device, and I'm a farmer, and they go out and take pictures all day long. And then if it identifies the diseased plant or an area, then it can go back and connect into the internet if it needs to. So those are the kind of things where you could do offline. It has to be offline and have that capability. We have something like the pre-built machine learning and online. These are kind of things you want to approach, like depending on what you want to do. Let's say we want to use some of these machine learning services like Poly or recognition. Some of these are just simple, send an image and recognition will send back tags and face recognition and celebrity identification. And some of the other things might just be a translation. I'll show you a demo of a translation app. So if you want to do English to French or English to German, there's an app for that you can do, and you can provide that into your app so that when you create that chat app, you can do the translation on the fly just by making a single API call. And there's also options like Google Translate also offers something like that where they take that model and actually put it on a device. So we'll talk about how useful that is for a customer to have that ability. And then you have an option here, number 2, is train the model in the cloud and then actually host the model behind an API. So that's like, let's say we have a super accurate and the model continuously training by the minute, like real-time stats, and you simply put the model behind an API, and then all the mobile devices or IoT devices actually call into that. Certain reason why you do that is maybe it's a really large data set, and it's too large to put onto the device. It's constantly being trained and changed, and then you can connect it from all the different devices. So the refrigerator, the phone, the desktop, all of it can connect to the same API and get the same information back by connecting in there. Now, the problem is that it has to be online to make that connection to it. And so in the offline piece, where you could train the model and actually deploy to the cloud. And I'll talk about what that means so it'll all kind of come together. And then the 4th part is using the platform APIs. So when you think about, like we talked about the Lex example, if you launch the app, like you have Apple, for instance, Apple has a great speech framework that I can use and take my voice, converts it to text, and then I can do whatever I want with that text. I can make call to Lambda, I can make call to as another API call, whatever I want, but it's completely offline and it's taking my voice to text, even though there's a lot of services like Amazon Lex that'll do the same thing where we can actually save that call if we want just that more control or that offline access. And then that's, again, the speech and then the vision part. And I'll talk about the vision part as well because there's services like Face++ that offers great APIs that'll do the mapping of the face and give you all these dimensions of the face. And a lot of you have seen like the art transfer stuff with some of the social media apps where it transfers and makes me a female or a female male, all those things, the style transfer is done on the device itself. So those are the kind of things we're using built-in framework where it could be real-time, and then you could add certain objects to it, and you could see the transformation being made. So a lot of this stuff isn't big science. It's just using the frameworks that are available. And you see on the lower right there, a lot of those social media apps are using that, where the eyeballs come out because they know the exact eyes. And as you're moving, those googly eyes just keep following you as you're going through. And it costs them nothing. They're not online, it's completely offline, just using the simple vision framework from Apple or Android. Okay, so let's do a quick take a look. So Amazon Lex is one of their chat bots. It does the voice to text, and then we have the text can go into a Lambda function, do whatever, really similar to Alexa. If anybody has an Alexa here, we have Alexa now in Toronto, right? Okay. So Alexa's works really great in the home. Think about this is the mobile piece. So if you're thinking about driving in the car, you have your phone in there, you can speak to it, say, show me a map of Toronto, or read my mail, whatever you want to do. As a mobile developer, we could simply add text to it, front this with my API, and then they can make those calls just as if they were touching or searching on the device. You've seen it on Waze, is another app that they use, and they use voice commands, so they can click on it and they can do a voice command, so the drivers don't have to interact with the device itself. Poly is just simply text to voice. Recognition does a lot of the stuff that I'll demonstrate with celebrity identification, a lot of imagery and video. So you can go in there and just simply tag the video or tag an image with sunset, chairs, whatever. And then you can do face matching if you want, like take 20, 30 pictures of each person in this room, and then we'll train it, and then it'll give them a name every time we take a picture, and it'll be able to translate it. A lot like Facebook is doing every day, like every time you take a picture. So this is going to be normal for you as a developer. If you want to provide these kind of services, you're going to want some kind of machine learning in there to kind of like enhance the app and make it stick out. And then there's transcribe and translate and comprehend. There's a lot of those text information that you can just send a lot of information in there, and it could understand like the feelings of people, like when they get feedback and comments, and it could do a lot of other stuff in the cloud itself. So when you think about these managed services, think about let's see, recognition. So recognition has a celebrity identifier. So if I take a picture, I send it to Recognition API, it'll tell me yes, it's a celebrity or not, and if it is, it'll give me the name of that celebrity, and that's it. So what's going on behind the scenes when we talk about that model, that's a custom model that Amazon Web Services or Amazon has created for us. And then remember that behind the API number 2, they've created this custom model, put it behind an API, and we're simply calling that API. Now, if we want that celebrity model, if we want to customize it, we would have to take that model, which unfortunately we don't have that model, but it's the same process. If we want that model to come on the device and not have to make that API call, we'd have to train our own model with our own celebrities and then put it on the device itself. So we don't know how large that model is. We don't know how many models are in it, whatever it is, or how many celebrities. We just know we make an API call and it tells us if there's a celebrity or not. So that's the part where if you just simply need celebrities, it's kind of a niche area, right? But if you need to customize it, then we get to the point where we need to build our own model and either put it on device or put it behind an API, just like recognition. So think about that. Think all of it is a model that they pre-trained with celebrities. And you can pre-train it with anything you want, any objects, bicycles, cars, inanimate objects, whatever you want to put in there. A lot of like dermatologists will use multiple pictures, like facial features, and they'll look at like skin blemishes, or skin cancers. They'll be able to identify those as a custom model. And again, same thing. I send the picture. The model tells me if it's a certain type of cancer, a certain type of skin lesion, and it comes back. It's all the same. It's just a trained model in the cloud behind an API. Okay, so I'm going to run through a couple demos just to kind of show you what that looks like, and hopefully this works out. So remember I talked about the celebrity recognition one. I'm going to run through a quick app. Hopefully it'll work. I'm going to end the show real quick, and then I have this set up. And I have QuickTime. So this I took a picture of 6 celebrities, and the spinning wheel is going in, which is my slowest, and then it pulls out. So I sent that image, which is 6 faces, and obviously it's not scaled very well, but 6 images, went back to recognition and pulled out all the faces, and then gave me a face to each name. And then as a developer, I can put those names anywhere, obviously. I could put it right over the nose because I know exactly where the map is of the nose. Or anyway, did it get everybody right? I'm not sure if it did. So that's the power of having a custom model with a recognition and using just a simple API call. And you can identify 6 faces. It could do like up to 100 faces right now, so we could do most of these faces. If you were all celebrities, I should be able to technically take this picture and it will list all the celebrities. And then in the app, if I want to look at Robin Williams, it'll pull up IMDb and take a look at that. So I want to do one other demo with that, see if that works. So recently there's been a couple sites out there that have celebrity lookalikes. And I'm not sure if you guys agree with this, but so this is a live picture. You know these two? So I'm going to take a live picture with the app and see what that looks like. So I'm going to take a picture. And again, usually it's about 1 second, maybe 2 at the most, if everything's going well. And again, it looks like it's super slow, but it's, we'll see. It should come back. But then it'll come back with the 2 names, put them side by side. And so that's the idea, is like the accuracy of this is pretty good. I mean, even though I don't think they look that much alike, but that's what this came from the site where they said celebrity lookalikes. Hopefully that'll run through. I'll run through another connection. But usually, and you saw the first one, which was 1 or 2 seconds, 3 maybe on the first one. And usually it's really fast. Like this would be ridiculous, right? You wouldn't work at all. But the idea is, these kind of things you can integrate in your app easily if you want to identify celebrities, or you want to create your own model and you want to identify certain folks, like all Amazon employees. If I took a photo of all the Amazon employees, I can go in there, and as they come in the room, I could just know if they're an Amazon employee or not, and then I could let them in, or if they're not part of a meeting, those kind of things. That would be custom made. Let me try it one more time, make sure, because I didn't connect. So I have this default app, just see if this works real quick, and then I'll try one more. That works. If not, I'll run to the next one, which is hopefully I'm connected. Okay, we'll do one more time then, since it's connected. Use the photos. We'll see. One more time back. I mean, you get the idea. There it is. So nice, a little bit more scaled. So the nice thing is this comes up, and you don't have to worry about the machine learning done all for you. So as A-list or B-list or celebrities go off the list, we don't worry about that. They're constantly trained. Now it'd be nice if we could just say, hey, I want this model and bring it on the device. That would be really great, and then we could do it completely offline. So then imagine the possibility. So if I'm on Rodeo Drive and there's a red carpet event, and I'm going down there, I could actually do my camera view, and in real time, if I had, let's say, 10,000 A-list celebrities, as I'm walking by, those names would appear in their nose as I'm walking by with AR very easily. I just need that model, and then I can pull it up, and then it's connected. So there's no connectivity at all, and I'm running against this app and making these connections. Or imagine a police body cam. They have the app running, and they're just sitting there drinking coffee, having their donut, walking by, and then they have their suspect list on the device itself. Bam, all of a sudden it just alerts them. They could be asleep, and alert them and tell them that there's a suspect or somebody in vision. So those are kind of the powers of having that machine learning kind of identify them. Even if it's misidentified, at least it's like it's a starter for them. And the more accuracy, the better, of course. But as you can see, and then you could adjust this to like 50%, 40% accuracy, whatever it is. I set it to like 75%. Don't show me if it's anything less than 75% accurate. And all these come back with that prediction. Remember, that prediction model says, okay, I've been trained on all these models, and I'm going to go look at this, and I'm going to say, all right, it's coming back Jude Law, David Beckman at 70, 80%. All right, I'm going to go show you. But if it's not, it may show you some other name that's so random that might not even work. So does that make sense on the connection and the model? Okay, so the other piece I'm going to do is, this is speech recognition. So this is back to the API-driven machine learning services. Remember we talked about Lex and Translate and all that? So there's Amazon Translate, which translates any text to a different language. And then I'm also using Polly, which takes that translated text and then speaks it out to me. But then also I'm using, the third part is that remember that fourth category where I'm just using the built-in framework? So as I talk, can you guys see that? As I'm talking into the camera or into the phone, it's my voice using the speech API. So nothing's online until I actually stop talking, and then it takes that text and sends it to translate. That translated text comes back, and then I send it directly to Polly for the voice. So hopefully the voice will work. We'll see. I'll do French. Okay.
Texte transcrit.
The quick brown fox jumped over the lazy dog. So see how fast that
Le
was?
renard brun rapide a sauté par-dessus le chien paresseux.
So you notice how the text came back right away. That was an API call on that slow network. That's a direct call to Amazon Translate. The text came back within less than a second. And then the audio, the MP3, took a little while because what it's doing is I'm sending the text back to Polly, and then Polly's speaking it back out to me in that French voice. And so that was a little bit longer, right, because it was a streaming MP3 voice sent back to me. But if it was just text, it was like lickety split, even though the Wi-Fi is really bad. So that's the idea. These kind of things, you can use the built-in machine learning that's already available. I mean, a lot of the services, if you go to the App Store, you can download, there's probably 50 apps that does the translation, right? But if you look at it, really, there's Google, Microsoft, those are the two that really are truly free. Everybody else will be free for a certain amount of time, and then they charge you through a subscription or through some kind of ad-driven approach, because it's costly, and somebody has to be doing that connection into the cloud. So this brings me to the other point, where we talked about offline. So imagine I was in Portugal last year for Web Summit, which was really cool. And I was using, Translate wasn't out at the time, or didn't have it available, so I was using Google Translate. So I was walking down the street, and I was doing Google Translate, and my connection, my Wi-Fi, my cellular connection wasn't that great. And then Google later said, hey, do you want to download this model in Portuguese? I'm like, okay. And I knew what it was, but I was like, oh, this is perfect for the talk. So what they're saying is, instead of making an API call to Google every time I want to translate, like, where's the bathroom, where's the library, and it's that delay, even a 2-3 second delay, they're going to be like, I got to catch this bus, let's get out of here. What happens is they can let me download that model like in a cafe, let's say it's 100 megs, for the 3 or 4 days that I'm in Web Summit in Portugal. Now I have this model on real time on my device, and it's split. I just do my voice, translates it immediately in real time, using their model that I've downloaded from Google, translate and put it onto the device. So that's the power of having that model on the device itself. You're not making any additional API calls. You're not costing any money to those developers. So let's say you're providing this service and you don't want to make these API calls. You could technically build or find a translation model somewhere in certain languages. Maybe you only support 2 or 3 that you're on, like Spanish and French, and you want to provide those. You could build those models, put them on the device itself, and so that voice goes to text, that text directly goes through that model and spits out that translated language in real time. So that makes sense, kind of how you can take it, whatever approach you want, depending on whether you want, or you're online or you're offline. Very powerful stuff, and having that ability to be able to take it offline is really nice. Okay, so back to the slides. So that was managed API driven. So try those first. If they work, if the celebrity thing works, if not, if you're doing a specialty for recognition that you want to do, like certain objects and detection, then you want to build your own model. So again, I took some photos or images of those just in case the demonstration didn't work out, which it didn't do too well. Okay, so number 2, remember we talked about a little bit earlier where it's like you could build and train these models in the cloud like the celebrity one. Just think about the celebrity recognition one, is we've taken that and then we put it behind the recognition API. Same thing you would be doing is taking that model and hiding it behind an API. Let's say it's 2 gigs. You can't just be throwing that around on mobile devices these days. And that's going to be changed in the next year or 2. I think we're going to see some really nice compression rates where we'll be able to see really accurate models and be able to push those to the device over the air. So one of the options is to actually take and use Amazon SageMaker, and I got my assistant here, use SageMaker to actually train a model, and then if it's too large or it's constantly being trained, again, some models need to be trained every minute, every 10 minutes, every 2 hours, whatever it is, and you can't be getting that on the device. You can actually use that and actually put that behind an API, and then everybody has that same accurate model. So you'll see that a lot of times if you want to be able to build in cloud and then store it behind an API. And again, the app has to be, it's required to be online, so that's an option. If the app's always connected, then you can make that connection. So again, train the model, deploy the model to a prediction endpoint, and then invoke the HTTPS endpoint. It's the same thing, just like thinking about a database. You're just taking that recognition model or that celebrity model that you built, throw it behind an API, and it's expecting an image of this shape and size or whatever it is, and then it'll take care of the rest. Or text or whatever that custom model is. You okay? Okay. So some of the use cases, requirements, network is available, reliable, application must support always on. Again, devices are not powered enough to local inference. So this is one of the other issues is, let's say we want to support India or China. Some of the older devices, a lot of them are 5 to 7 years old. A lot of times they're not even connected to the internet unless they go to cafes. So there's a lot of issues there. If you want to support those products and those users on a daily basis, a lot of times this would be really tough to do. And you may want to do obviously you'd have to do the endpoint, but maybe you'd want to take it offline if you can. And hopefully they can get to at least make an API call. But there's different options depending on where your users are. And you can mix and match too. So in the US, maybe you do it behind an API. And in those other countries where the connectivity is not as reliable or the devices are older, then you can go do a different option and be able to provide different solutions. Okay. So, number 3, this is the big part of it. This is where we can download a model, and I'll do a quick demo of it, where we can train the model and then we deploy it to the different devices. And I break these down because a lot of times when we talk about the best tool for the job, I'm not a huge cross-platform, one set, they work for all. The nice thing is when you build these models, if anybody's used TensorFlow or MXNet, it doesn't really matter what you're training it in. All of them have a capable script, scikit, whatever. You take and script it to a CoreML model or a TensorFlow Lite model, and you put it on the device. Now, TensorFlow Lite does work on iOS, but again, use the best tool for the job because iOS has done a lot of work with CoreML, and the same model that you're using to train, everything is same accuracy, same size. You're just converting it with a script to a TensorFlow Lite model and a CoreML. You're putting on a device, and then the device itself knows exactly what to do with that model, whether it's an image, text, voice, whatever it might be. You're putting on the model, and it's completely offline at that point. So they'll connect into it. And I'll show you what that looks like with the regular image that I downloaded from Apple. And then the web, you can use a combination of TensorFlow Lite. You've seen a lot of talk about doing machine learning on the browser itself. And that's coming down the pipe. Okay, so some of these advantages, So some of the advantages, the mobile first, low latency, offline capable, always available, and privacy. Privacy is another one we didn't really talk about, but if you're doing images, like maybe you are doing nudity images and you want that, and that's part of your job, then you want to be able to protect that privacy or protect someone intellectual property or images, whatever it might be. They can upload those images directly to the app, encrypt it doing something else, or do prediction on the device itself, and it never makes it to the internet or never has to make an API call. So those are kind of really great options to have that available to you. Okay, so real-time object detection is one of the other things about deploying model to the device. Is not only we'll have the offline, we'll have privacy, we don't have to be connected, but we have the real-time aspect now, which is the really cool piece, right? Where you look at an image and it's immediately transforming your world as you're going by. So we're talking AR, which hasn't really taken off too much for mobile devices, but in AR with a vision, you'll see that it's actually not as crazy as you think, but actually real practical when you're talking about a mobile device and putting that device, that model on the phone. So here I got an image, and I'll show you what the demo looks like. But I downloaded a model, which is 1,000 everyday objects. You've probably seen this before, shoes, chairs, whatever, just like recognition uses, right? So it's a custom model that we've downloaded. It's 100, 200 megs onto the device from Google. There's Inception, there's the ResNet, whatever model we want. We take it down there, put it on the device, and then we're using ARKit, so we're scanning around, and it's immediately sending those images of 25, 30 frames per second to that model that's on the device. Totally not capable. Remember that the recognition celebrity one we were talking about? That's where if we were to scan the room, it would automatically, real time, be able to scan every face and then identify those names immediately, versus if we're making an API call, we can't just necessarily scan. It'd have to make API calls throughout. So this is what we can use for offline and have access to those models. And I'll do a quick demo of that real quick. I'm going to switch devices real quick. Now, by the way, this is a 2014, so 5-year-old phone that I was doing it, so it doesn't have ARKit yet. So I'm just switching over so you can see what the difference is. So see the confidence move around? The idea here is not really the accuracy, because 53% is not that good. And if it goes to laptop and confidence level, detected notebook. This usually detects it as an iPad. And remember, it's dominant images. But the whole point of this is, if you see the motion moving around, you see the prediction live. So imagine each one of those predictions would have been like an API call to the internet or to recognition, versus these are 30 frames per second going into that model. So it doesn't show anything unless it sees something in there. And again, see a 74, 64, 65%, and then identifies. And then it'll identify people if it gets close enough. I don't know, let's see if it identifies. Neck brace. Ah. That's pretty cool. Bathing cap. Oh, that's so rude. Jeez. All right, we're not doing that demo anyway. But you see that the nice thing about that could be anything. That could be the celebrity. That could be the police cam. That could be all of it. And this could be the security cam, right? And so anything we want to track, we pull up and it pulls up detected stage. That's nice. So anything it pulls up, we can actually translate that and take action on it as a mobile developer. So anything come back. If we're looking for, let's say, we want a female in glasses, take a picture. Or like I want to see somebody wearing Brooks running shoes. You know, maybe I'm tracking shoes and I'm just in here in the mall and I'm looking down at everybody's shoe. And if it identifies a shoe, it tells me what it is. Or if I'm doing a competitive analysis, all I have to do is know the difference between a Nike and a Brooks, and I could just scan all day long, and I'm doing market research in this entire room right now. So with this real time, and then it's collecting data, and either you can send it back to the servers, send it back to AWS Cloud S3, or you just store it on the device and then upload it later. But the nice thing is these devices are fully capable of doing so much more than just doing a picture and sending it over, because we can get the model on the device and do some real-time stuff with it. And again, this doesn't look like your typical AR stuff, but it is. It's like, you know, in your own environment. And imagine what you can do with that offline capability. So really powerful stuff. And if that's one of those options in the app that you want to do, you see those social media apps are making millions and millions of dollars off of this simple technology of getting a super silly model and understanding where the eyes are and where everything else is. So it's really strange. So I'm going to switch back to this one real quick and show you what that, the last piece of the built-in. I'm going to show you that, and I'll run back to the last slide. This is actually working pretty well. Go back to my 5-year-old phone. Now that I say that, everything's working great. Okay, if that doesn't come up, I'll go back to the slides and come back. Boom, yeah. Okay, so this one, I'm going to take a picture and use the built-in framework. This is number 4. So I'm going to use the built-in vision framework, where it takes a picture of my face and then maps the entire face. It'll put all the dimensions in, including my eyes, mouth, everything else. Let's see how it works. So if I go like this, so this is built in. This is built into the framework. But the nice thing is, when we do this real time, this is what I was talking about when a lot of those apps will use the eyeballs and the eye gaze. There's also the app with the eye gaze. You'll see a little thing coming out of both eyes in real time as you move up and down. That's full eye gaze. So if you've seen those accessibility apps, a lot of that's what they're using is the built-in framework. So they know if I'm moving up, if I'm moving down, sideways. If you're anybody's an Android user, you probably have that feature I turn it off because it's weird scrolling with your eyes. But that's the idea is now I could do anything. I could put lipstick on myself. I could change my nose. I could change my eye color, my eyebrows. And again, this model was just taken with a static image, but the real-time one is where it really becomes powerful because you're moving around. And imagine a lot of this video post-production, and they're doing the real-time apps, and then somebody drops their drawers or something, and it's like post-production, you have to do a delay. A lot of times, this can be taken care of in a live feed where it'll automatically blur out in a split second and be able to blur out that nudity or blur out somebody's face or whatever in the crowd. I can scan by and I'll identify all eyes and put a gray bar across everybody's eyes, real time. So those kind of valuable for production, so you don't have to go in post-production and do all those the maintenance, or at least it's a starter for them so they can go in and just blur out the final aspects. And you've seen Google, the Google Maps, the same thing, right? You've seen Google Maps where you pull it up and you'll see somebody's face blurred. Imagine if they had to do that manually and go through every face and go, I mean, that guy would be dying by now. I mean, he's already quit. But machine learning, it could just go in and say, it knows it's a face, blur it out. It knows it's a house number, it's a business, it's a trademark, whatever it is. All of it, just block it. Just highlight it out, and then we do some visual inspections. And as we've seen before, you can pull up, and you'll be able to see people's face clear as day because the machine didn't quite catch it all the way. So these kind of things are really cool for developers, and this is what a lot of those social media apps are using for scanning the faces. And not only that, but you'll see that box. So this is available, and you've seen the box when you're taking a picture, right? In your face, there's a box moving around. That's always there, and you could, as a developer, you have access to the full rectangular box. So if somebody takes a weird picture, you don't have to get a picture there. It could just say, take a picture, isolate the face, and then send it to recognition, or send it to somewhere else. Because really, if you're doing facial recognition, you only want the face, you only want a certain direction of that face, and you want to get the most accuracy you can. So you can just take that rectangle and say, okay, here it is. And so this is giving you like 80-something points of present. I drew like a cheesy little line over here, and all these points of presence tell you center of the eye, left gaze, is he looking left, right? And then you can actually say if that person's sad or not. He looks pretty sad. But there's an app out there that says that I could smile and it'll take my picture. I mean, it's very simple, right? Just go there, and if you just look at it all day long, and then you go, and it takes a picture. All it is using that custom model, real time, looking for a smiling face, 50% more accuracy. Let's take a picture. Very simple, but very great, right? Selfies all the time, cheese, and then recognize that voice, the keyword, and then you're gone. So all these things that are capable with a mobile device. All right, so let me see, do I have one more demo? Okay, we did speech, okay, recognition. Let's go back to the last bit of slides and take a look here. Okay, so here, this one, you can see a picture of it. I don't have that demo, but that's sort of the points of presence. And then at the live demo, maybe I'll do it tomorrow because I'll do the same talk, where you can see the box and it's moving, and you see this little, see the eyes in the middle picture. You see the little lines there, the left and right eye. That's the eye gaze, and those things move up and down to let you control. So again, all this is built into the framework, completely offline, no machine learning going on, but it's all built into those frameworks for you to take advantage of. So you're not like, I'm doing machine learning, but you are with some of the built-in framework. Okay, so let's recap. Remember, we had the managed service, try out some of the managed API-driven services. So if you want like translation and Amazon Poly and translate work for you with those languages that you want, great. But if you want some language that's not supported, or you want a few of them that maybe are offline, then you need to build your own. And then if you build your own, you either put it on the device or host it behind an API. So the custom machine learning one was train the model, hosted behind the API. We talked about those different options, the reasons why. Maybe the device doesn't handle the size of the model, and the model needs to be continuously trained. And then you can connect it from any device, IoT devices, mobile devices, desktop, everything's connected. Because if you remember, when we were looking at the offline piece, we have to kind of like configure the iOS and the Android device as well. And there's differences between iOS and Android, right? So some of the Android devices, a lot of them can do machine learning, but they have to be, I think it was 3 or 4 years old, and they have to have one of the recent operating systems. And that's one of the tough part about Android is the fragmentation. So if you go and create this app and you want iOS and Android, you're going to be like, whoa, I need the Android devices, and you're going to be limited to maybe 25% at best of the entire population of Android devices. Remember, Android's the largest operating system, largest in use operating system in the world. But when you start breaking it down to using some of these machine learning and even inference, the simplest use case, you're going to lose 50% of the entire Android population. Why? Because most of those are in third world countries, and they're simply not connected, and they're super old, and they can't even run a simple inference. So you'll see that in the Google Play stores. A lot of times you'll look at it, and they can't play probably 99% of those games in the App Store right now. And you'll see it. You'll come down. And that comes down to the fragmentation, comes down to the devices. The cheaper devices are always available for Android. And then iOS, again, that was 5 years old. I was able to run everything except for ARKit because ARKit's fairly new. So think about those when you also develop the app and say, oh, I'm going to do ARKit, and I got 2 billion users. Well, wait, I could only do 1/10% of that, and then maybe 20% of iOS users. So now I'm down to like millions. So think about that when you're starting to develop the app and figure out what's the best use case. And you don't need to necessarily have the same feature for both iOS and Android. I know a lot of developers think everything's got to be in parity, everything's got to look the same, but nobody's looking at an iOS device and an Android device at the same time going, this app looks different. I don't care. Nobody cares. So, and again, the platform API, Apple Vision Framework, there's the Android speech, so speech, vision, there's lexicograph, a lot of stuff that you can do like identify names and features and certain trademarks. Like if I go Amazon Web Services, it's not going to mistake that, and it could actually shorten that to AWS for me. You could do that on the device itself right now and call out certain trademarks. Or if you want to build out your own custom, if you have certain keywords in your company or your business, you can actually call those out and make them really stand out. So when you notice, like when you were searching, we do iOS, you notice how little I, uppercase OS. Oh my gosh, it's magic because they own it and they have control of it. So they've figured that out. So things, if you have a certain trademark or certain keywords in your app, you can actually do that with machine learning as well. And so try out the pre-built stuff. If you want to host it behind the cloud, there's that option. And again, I didn't really talk about training, but the idea is we're using these trained models. There's a lot out there that are available to us in there. So I'm going to show you real quick. How many more minutes? I got 10 minutes? 5? I'll show you real quick. So this one, oh, never mind, I'm offline. Oh, I'm offline, but here's the models. So these, remember I was talking about the ResNet, Inception V3? So those ones where I identify the tennis shoes, these are the pre-built models. So think about this, if when we were looking at that recognition celebrity, think about that model being here, recognition celebrity, Core ML, and I download it. It'd be exactly the same thing if I went to recognition and downloaded that model from them if they were make it available, and then I could do it real time. So any of these would work for everyday, a lot of them for everyday objects. This one's, I think, about 90 megs. That one's about 92 megs. And you put the model on a device if that's workable for you, and then it could just simply identify certain objects for you. So the nice thing about that is if you're allowing those users to upload images, right? And you want to index them or tag them, chairs, outsides, umbrella, whatever it is, you could make an API call to recognition, or you could use these everyday models, put on the device. Every time you upload an image, it could tag certain items that it goes in there and scans. The dominant features in there. And then now you've created this nice indexing of this app offline, so those users can go and say, I want to pull up anything with an umbrella or anything with sand, and then it comes up, all offline if they wanted to. Or you could just send it to your host and do some more stuff on it as well, and more analytics. So there's a lot of stuff, and then recognition also does the face matching as well. So you set up a catalog of those users. We talked about that security app where you could set up a catalog of like 3 or 4 people or 20 people, and you take 200 or 300 pictures of each person and then tag them with a name, and then from then on, every time you take a picture of that person, it'll tag them. So if, say you have an app that's like for buddies, and you're out on a ski trip, every time you take a picture, there's 3 or 4 of them, it sends it to their email or sends them to the app automatically because it knows who they are. Automatic sharing, it's ubiquitous. It's all those kind of things are capable now with simply identifying who those folks are in the image, if you want. So I think I'm going to stop there. I'm going to take a few minutes for questions, if anybody has any questions about this whole process. Any questions? Sorry. Oh, if anybody wants to see the...
We did get a question on Twitch.
Oh, hey, Twitch.
About model size. So would you get more, would your model size grow exponentially based on the number of characters that you had, or just the number of pictures that you had there, or how would that relate to the model size?
Yeah, it varies. Typically, it's the higher accuracy of the model, the larger the model is. And that's kind of the high level part of it. But yeah, and there's certain ways that a lot of the cloud providers are using algorithms to shrink those and saying, I just need that last layer. What part do I absolutely need for the mobile device to get it on there? And so we'll start seeing that compression algorithm go way down on some of those. So yeah, typically it's just the more accurate you want it. But if you want low accuracy and you want it just super small and you want to upload that data, and again, both Apple and Android offer over-the-air updates of those offline models. So if it's like, say, 2-3 megs, and you've trained on a few family members, you can actually offload that and put it on the device without going to the App Store once a day or twice a week, whatever it is. So that's an option, as long as that model's within a manageable size. And sometimes you force, accuracy, play against accuracy versus size. Yeah. Anything else? Any other questions on Twitch? All right. Thank you.